Okay, can you hear me? Okay, good. All right, I don't have any set agenda because I haven't introduced homework assignment number 2. Yes.
How we submit
The homework 1, part 1, right? No, part 1 or part 2?
Part 2.
Part 2, okay. Part 2 is actually go to hand in. Hand in, go to CSIF.
Are you able to show us?
Sure.
Are we still supposed to do part 1?
Yes, we will. But right now, the network is probably being resolved. I'm actually still discussing with the COE, College Engineering IT team. They probably will just let our server, the server you will be accessed, basically be allowed to go in using any network or at least the library, DCS.
Just submit the second part for now. And then
Yeah, you submit the second part. Part 1, you don't need to use hand-in to submit anyway. Part 1 is just online, communicate with the network.
so whenever like part 1 is like actually working, would you be able to just kind of go over and kind of do it?
Part 1?
Yeah,
Sure.
like whenever it's working.
Okay. Yeah, I will do that.
Yeah.
I will do that. Right now, I can show you how it works. But because I have a VPN access, and they only open the network service to faculty, staff, and graduate students. I told them we have 180 undergraduate students. Yeah, but the thing is, pretty much every single homework after that, we need that. So we have to let you get access to that as soon as possible. I mean, this is the first one is really almost you don't have to do anything for this particular one. Just use the command. Let me see if I can SSH to CS. Hold on, my internet may be connect. Okay, connect. Kind of really slow. What? 1 second. Try my... Okay. This account, I cannot do that. Okay, so I want to just give very quickly about what you will be looking like, because this account on mine, but the other account, master account, for some reason doesn't allow me to log in. But essentially, when you go to, this is CSIF machine. Inside CSIF machine, there you can log into any one of them. You should already, your account should already be included in the list. That's how I get my master list from this class. So within this list, you can use the command called hand-in. This is only you can use it here, hand-in. So if you follow the homework assignment number 1, instruction word by word, that's actually, I think I have, let me just bring it up. Okay, so this is the hand instruction over here, this part. So this part, of course, under the CS, you have to do the create the directory, change the directory. After you've done tar, using tar command to do that, this is the line of the hand command. You can submit your homework, this line. That's the command, but you cannot do that unless you log in to the CSIF machine. Okay. All right. I said I don't have a set agenda. I do want to have some administrative announcement, and then I will open the floor to any kind of question for any parts of this class that you can ask. Okay. So I think I have been really impressed that our students have been helping each other, and I just realized I actually know that maybe a couple of days ago, and today I actually talked to some students. I mean, I really appreciate some of you already create a group for this class in Discord. I think that's great, and you should definitely use that. And the second thing I said, if you haven't been on that Discord group as a student, you should definitely go there. I think you should go there. Discord is a very cool application. You will find a lot of help. You can share the issue that you have. The third thing I want to say is I actually I feel it this way. I checked with TA as well. We feel that none of us should join the Discord group because you probably know the reason. Because I want to make sure that that's the space that you feel really comfortable. All students, that's your group. That doesn't belong to the instructor or TA. That really belongs to you. And you can actually, some of you might summarize the issue you have, and maybe you can resolve the problem by yourself. Great. If you cannot, then somebody, moderator or one of the students, can actually just bring the issue to me directly or bring the issue to the platform that we're going to create for this class. So we talk about different platforms. We think that which platform is probably best as a official the platform for the class, for the instructor and the TA, announcement, answer. We will use a Piazza. So the TA will create a Piazza site. So you can actually, this is my feeling, to get something really quick from yourself and to discuss and just for fun, I think using Discord is great. But when the particular problem in hand is kind of being obvious, that is, you need someone, or actually we have something we want to tell you, we will use Piazza. Of course, whenever you go to Piazza, realize that this is an interesting issue. You can actually post link on the Piazza over the Discord group. Okay, so just let you know that this is what we will be doing, and I want to both encourage you, and I want to praise you for communication over Discord, and I want to make sure, okay, and it's a student-only group, okay. That's what I want to make sure. Of course, I will not create a fake Discord account and try to go in there to say, okay, if I do that, that's actually ECS 188 to deal with. That's unethical behavior, right? Okay, all right. Okay, great. All right. I hope to address the VPN issue so I can roll out. Just let you know that homework 2 is coming. And then shortly after that, I'm actually going to start launch homework 3. I mean, homework 3 is actually a killer. I just want to tell you. I'll give you extra time. You will need Discord, office hour, everything. Okay, and you need to help each other. It's usually homework 3 is the one that the student make me sleepless until 1 a.m. Okay, just let you know that it was a Zoom meeting until like really late. Okay, homework 3. After homework 3, everything will be just hobby. Okay, just let you know that. Don't be scared. After you experience homework 3, the rest homework will be easier. Yeah. A little bit more, a little bit more. It's probably 20%. Probably 20 or 16, I forgot. I forgot what it is exactly. But let me actually tell you homework 3 is. Homework 3 is essentially combining a few concepts together. Essentially saying that you run a program on your computer and you run another program on the other computer, like the server, and you have you remember you call member function, right? You call member function, you have both the driver and the member function running on the same machine. Now what we're going to do is that we're going to do something called remote procedure call. It means that you're going to start it from your computer. You're going to call a member function on the other computer. What?
That's my question. Possible?
Yeah, we're using something called RPC, JSON RPC. Yeah, it's a library under C++. It's a library. It's part of the library. It's already being built in to CSIF, and also you can actually, I will tell you how to install that. If you don't want to install that, CSIF already have it installed. So essentially, let me just tell you the details. A lot of things you will see is conversion. You're going to convert a call that you're going to make on the other side. You have to convert that call into JSON. And the JSON is the string you're going to deliver to the other server, just like homework assignment number 1 will deliver a JSON. Okay? Over there, they're going to convert that JSON back to the call. And then they're going to call the real function. That's going to happen. And then in homework 7, homework 6, you're going to do something even cooler. Is that what you're going to do is you're going to convert the whole C++ object into JSON and send the JSON to anywhere in the whole world. And then over there, they're going to convert that JSON into a C++ object. And then you call that object. So it's basically, you can do a lot of things with that model. That's essentially what all the companies in Silicon Valley are doing today. Yes? No, oh, okay, I never say this. And I'm sorry, I should have said that in the first slide. In my academic career, I actually became a faculty member in 1994. And at Columbia University, because that was my last year, finished my thesis, the department wanted me to teach software engineering programming. And then I became a faculty member after I got my PhD in 1995. So you can count, I have been teaching for how many years? Maybe 26 years, 27 years. I have never curbed even once. Okay, I actually honor a learning paradigm called collaborative teaching, collaborative education. I believe students need to collaborate. And curve, put any kind of curve, kind of put a pressure on students to compete. I want to remove that. So I never curve in my career. I always say that, by the way, it's recorded. If you look at my video, but at some point I say that. Okay, so I like you to help each other. I like you to independently develop, but yet you collaborate with each other. And that's the best way to work in the programming, because you're going to do exactly the same thing when you graduate from here. You're going outside. You're going to collaborate. You're going to trust the system. Okay. Even though sometimes we have problems, but yeah, we deal with the problem when that occurs, but we trust as our default and we collaborate. And then I actually remove the curving part of this. So if you look at the grade, anybody do a curve on the gray eye distribution, it's actually going to be very different from a typical professor that's actually doing the curve. Any other question? Yes.
So I saw in the homework with the after submission, you have to like put a make file in your homework. You have to actually write a make file.
Yes. You have to write a make file, or just copy a make file and change it for this program. Yeah. And for me, I actually hardly ever write a make file from scratch. Always find a template. Yeah. Go on. Okay, any question you want to ask? Yeah.
The big file is just
You go.
the big file is Java. Okay, we have
We don't have an exam.
okay.
We only have, okay, let me tell you, this is important. We don't have any exam. We don't have a midterm, we don't have final. Because I don't know whether exam can help us to test our creativity, innovation, about how you really know how to solve a real world problem. I mean, I don't believe, at least for this course, not for Professor Goldstein. Professor Goldstein will make sense to have a final exam. Over here, programming. I don't expect you to remember every syntax because whenever you need something, you can Google it, you can find out, okay? But I have interactive grading for the final project. I'm going to spend a lot of time. We spent about maybe last 4 weeks to dedicate to final project. I take students into group. And I meet with each group at least twice before they did the final presentation. And they're going to develop something. I'm going to see how you're doing. And so that's interactive grading. That is actually going to take, I think last year it's probably 25% of the grade will be on that. So that is I can ask meaningful questions and I can ask how you react to some of the situation I described based on that. I'm going to tell you more detail about how to grade final project. Okay. Yeah. Yeah, we'll make it available on the campus wherever it's ready. Maybe in the back first. 1, 2, 3, and 4. Okay, please go ahead.
Can this work the only file or is it not necessary?
Makefile is necessary. You have to have a makefile because when TA receives your package you hand him, he's going to type a make and he's going to run the program. Yeah, because I want to push you to get into the habit for makefile because homework, subsequent homework, they all need makefile is growing bigger and bigger. Okay, yes.
Are there any other
Okay, basically 3 is hard because you never done that before. But pretty much 4, 5, 6, 7, except 4 maybe. Everyone is bigger and bigger. But everyone built on the previous one. Essentially, all of them build on number 3 as well. You're going to reuse number 3 a lot. Yes.
Would you go over like the basics and how to write a makefile?
Okay, I'll do that. I'll do that now.
So, can you use the auto-generated makefile from ID?
You can do that. Okay, you can do that. That's fine. But it will be good to learn a little bit about how to file this. Okay. Any other? Oh, you have a question. Sorry, I'm sorry. Yeah, go ahead. Can you speak a little bit louder? To test your program, right? Yeah, okay. So I actually described a little bit about how you can test your program. Okay, this is important. Please listen here how you can test your program. Suppose when you break and you peel back, the program, the original file you break should be identical to the file and you just regenerate it using an appeal, using the facility called DIFF, DIFF. There's one part which I didn't say it clearly in the exam. You want to handle some error situation. So what you will do is in that process to remove a chunk. Say you have 20 chunks, remove any one of them. Say remove chunk 12. And then you do the heal again. Then your program should actually stop. Should not try to just put back because you're missing one chunk. It need to detect that, and then it will just quit, and then print an error message or something. Say there's one chunk missing. Is that answer your question about testing? Okay, if you have more questions, any one of you more questions, I can come back. Yes.
So what kind of readme file are you looking for?
It's just how you're going to run your program. Whatever, if you have some, for this one is really, I already put everything in the homework specification. So for my field, those 5 parameters should be exactly identical. However, if you want to say, I mean, for example, make file I'm going to talk about, by default, I should just say make, and AKE it should automatically pick up. But if your make file has any kind of parameter I need to worry about, you should describe that in the readme file. Oh, the other thing is important. Your student ID, your name, should go into readme file as well.
Oh, so my make file is basically like you know automatically my break and my
Yeah. Pardon?
I mean, my make file of how to program that one.
Right.
That's not.
Yeah, that's fine. Yeah, you can compile 1 or 2 together. That's your choice. Yeah. Okay, so I'm going to show you how to do. So now I'm going to just do a little bit of make file. Okay. Let me see where it is. Where did I put it? Maybe I put it in homework 1. Do I have my break here? No, I don't have my break here. Oh, I do. I do have a make file. Okay, this is just show you that this is, you can use it if you want. This will be recorded. I just want to tell you, explain to you how makefile works. It's an example. I mean, you can basically copy this, that's no problem. But you need to learn how makefile really works. Okay, so essentially in a makefile, there is 2 different sections. One section is just defining macro. And the second section is called rule. And I will explain. The rule is really important. So essentially, in this makefile, let me see if I can put everything in one page. Yeah, this is everything. Is that everything? Hold on. No, it's not. Okay, so let me make it smaller. Okay, that's the whole thing. Can you see it on the back? Okay. Sorry, I just want to fit everything in one pages. So there are 2 parts. You see there is a middle, there is a rule, right? There's something called rules. And before the rules, everything is what I call a macro. I essentially just define what is CC. CC, capital CC is GCC. And then C flag is something I actually provide extra parameter to the compiler, to the GCC compiler. I mean, later it will be G++ compiler. In that case, I will actually change that CC to. Let me just show you what it looks like in a different homework. Let's go to homework 3. I don't have homework 3. Oh, sorry. Now, homework 3 WR. Okay, homework 3 WR. So you can see that this is my homework 3's makefile. The same thing, the capital CC now the G++ minus STD is equal to C++ 14. So capital CC is just a macro. I use it as a convention makefile to tell them which compiler I'm going to use. Okay, so CC actually stands for C compiler. All right, so that is just, you can see that it's always have a CC, always have a C flags. Okay, now I'm going back to this one. Oh, no, not this one. Yeah, I want to go this one. Okay, so the first line is CC is a compiler, C flag is just a parameter. I'm going to use it for my GCC compiler. So now let's see the rule. So a makefile rule has 3 parts. One part is the name of the rule. The second part is what we call dependency. And then there's the other part called action. You should actually take a look at the makefile tutorial. They actually give you a more complete introduction to this subject. Okay, so let me actually give you an example. What do I mean by the target, the name, the dependency list, and the action? For example, if I look at this rule, this is the rule. And this is the rule as well. Okay, so you can see that the rule is target, dependency, and the action or rule to generate the target. So in this rule, the target is my heel.o. I'm doing separate compilation in this makefile. So my heel.o is actually the target I try to generate. And what's the dependency? How do you actually generate my heel.c? Oh, sorry, my heel.o. You actually need my heel.c because you use the C program to generate the object file. Okay, so the dependency is actually my heel.c. Okay, so this is important for first-time makefile user. Have you noticed that I actually keep some space in between the target and the dependency, and also I keep some space from the first column to the action part. That was done syntactically. You have to have those space. And those space, by the way, listen to me carefully. They are not space. They are tab. Everything has to be separated by tab in makefile. At least that's last time I checked. Unless they fix this totally different. So in other words, what I'm saying, if you look at this, my heel.c, if you do a backspace, so for example, over here, if I do a backspace, immediately just one backspace, it wipe out because why? It's a tab. So I use the tab key to create this. Similar for this one is 2 tab. This one, you can have a 1 tab, 2 tab, that's okay. But in makefile, to separate this 3 type of entity, you cannot use a space, even a single one. It has to be all tab. 1 tab, 2 tab, 3 tab is okay. Okay, that's just makefile crazy thing. I don't know why. Okay, but a lot of student or first-time user for makefile just saying, why my makefile doesn't work? Because you have to use tab key. Okay, instead of space. Okay, so let's go back here. My heel.o is the target. My heel.c is the dependency because I need that. And then this one is action. Now let's look at this. This saying that, well, if you actually, the dependency list is there. I will explain to you why is dependency list. And then you have the target. How you generate the target, we're going to ask you that command. That command is what? That CC, you see that? Now I have a $sign parenthesis. $sign parenthesis CC, that means you're going to replace that with the macro we defined earlier. So that one is the same as actually say, instead of saying this CC, just GCC. Okay, I'm just replacing that. But using this is much better because when you have a different option, you can just change. For example, let me actually give you an example. I might have two different versions of a compiler. So one is G++. So I just basically comment this out. By the way, $sign means comment that out. So it means that at this time, I'm just changing over there. I can configure my whole makefile different. Okay. Any question before I move on? So I just want to, at this moment, you just understand there is something called rule. My hill.o, my hill.c, target, dependency list, and action. I haven't told you that how to file this rule, but I'll explain later. Any questions so far? Okay, the second part, I want to introduce another rule. Another rule. Another rule here is my hill, this rule. Again, I have a target, I have a dependency list, and I have action. So my target is my hill. That's the executable I'm going to generate. And then I have a dependency list, which is my hill.o, because I need to generate the executable, I need object code. And then the action is this part. You can see that I just basically compile the code, generate my hill, include my hill.o. Okay, this is another rule. Okay, let's see how this rule is being triggered. Okay, I use the word trigger or fire. Basically, how will you actually make the rule to really do something? That's actually what make when you type make. So let's assuming when you type make, you see that my first rule doesn't have action. My first rule doesn't have action. I call it all. This has a target all. It's just a default target. So it has two dependencies. One of them is my field. The second one is my break. So let's actually see that what it will do. When you type make, it will actually look for the first rule. And then it will actually look for the first dependency, my hill. And then when you look at my hill, it's actually going to check whether my hill is already there or not. So in this case, because all is not there, so my hill will always be triggered. When you type make, trigger the rule all, there is no file for all. So it will always trigger my hill. So then you're going to say, okay, I want to generate, now my target is my hill, then the make program is going to look for every single rule in the make file and see which rule has my hill as a target. So it will actually find out that this is the rule. They actually directly from here, it will actually first trigger this one. It will trigger this one. So when it trigger this one, my hill, the first thing is going to check whether it has my hill.o, right? Object code, because you want to trigger me, you have to give me the dependency. Okay, so there are two cases. My hill.o is already there. So you just directly execute the compiler. I will tell you what do I mean by already there. Okay, it's already there, updated, you just call that. Well, what happened if my hill.o was not there? When you call the program, now I have a dependency. Now that dependency becomes target. Which rule should I trigger? If my hill.o is never there, which rule? The rule, my hill.o, right? Now this rule is going to trigger this rule. Sorry. It's going to trigger this rule. So you can see that this is from the final product you try to have. It actually searched for this rule and dependency. It will, like a chain reaction, it's going to trigger other rules, which will regenerate the components that you need for the final product. That's the make file. I mean, this, you don't see the power because it's only have like a 2 or 3 files. But imagine you have 100,000 files trying to build together a large system. And just imagine you just type make. It will automatically figure out which one you need to compile, which one you need to generate, which library you need to create, and it actually help you to manage your project very well. Essentially, all the IDE that you use, including ESC, they essentially follow the same paradigm. But the only difference is the Visual Studio Code, sorry. They actually use Python to represent this rule. You check your BSc, they not use Python, use JSON to represent the rule instead of using this kind of tag rule, okay? All right, so any question about Makefile? Yes.
Is there a way to test if the Makefile works?
Yes. I will just say make. Okay, make, clean, make. Okay, if you see that when I say make clean, oh, I will explain what make clean is. But if you type make, it actually starts to do all this. You see the rules being triggering, then you know it's doing that. If it's not, it will give you syntax errors and make cannot handle this, cannot handle that. Have you noticed that I actually did called make clean? So let's actually say what is a clean rule I actually did. So I have a rule, which I probably should get rid of this. You see in the last line, make clean. Make a clean is a rule. It doesn't have any dependency. You only have a target. But whenever you say make clean, it will actually remove all these files. It means that when you have a more complicated system, sometimes you just want to recompile everything. But you want to make sure you have a compilation that from scratch. What you did, usually make clean, we actually remove all the object file, remove all the, later you will have something we call core dump, where you have segmentation for. Some of you probably already experienced. In 36A, congratulations, you will have more this folder. And you just want to remove that core and remove the executable. You just want to do a clean regeneration of the project. It's just like when you want to release a piece of software to another team, you usually do a make clean and make all. Just remake everything, make sure that everything is okay. Okay, so any question about the Makefile? Okay, I just want to tell you one thing, which I didn't say about when you should trigger a target. Take a look at this rule. My heel.o is there. And my heel.c is there, definitely. When you say make my heel.o means that you want to generate that my heel.o. How do we decide whether that particular rule should be triggered or not? That's the whole trick about Makefile. Yes.
The file has changed. Source file has changed at all.
We want to compare which one of those two are new in terms of their timestamp. So every file has a timestamp. If you do a ls-l, you will see when was the last time that this file was modified. So my heel.o has a timestamp. My heel.c has a timestamp. If my heel.c's timestamp is newer than my heel.o, this rule will be triggered. If otherwise, it will not be triggered. So that's the trick about make. When you type make, the make program is trying to follow this network of rule between target and dependency and check their timestamp. If the timestamp is newer than whatever the dependency, then it will not generate. But if it's older than the dependency, it will generate. Think about when you modify my heel.c, you change it, and so it will have a timestamp that's actually newer, then that particular rule will be triggered. Okay. Okay, hopefully that gives you at least enough information or example for you to write the Makefile for homework assignment number 1, right? Just be careful, that's not space, that's tag. Other than that, I think you're okay. Yeah.
Sorry, stupid question. What is the dash F5 do for the ORM?
Where?
So ORM dash F at the bottom.
Oh, minus F, dash F, that's forcing. So sometimes if you have a remove RM, I don't know if you do that. I actually alias my rm command into rm minus I. Rm minus I means remove interactively. Means that if I, by any accident, I type rm, it will not just blindly remove everything. It will actually ask me, do I want to remove this file? Do I want to remove this file? That's what rm minus I is doing. So my rm is already rm minus I. So rm minus f is basically saying that if you have rm minus I, ignore it. Just go ahead and remove everything.
So follow-up question, the alias is like on your batch or two, do they apply even in the makefile?
Yes, it is. It's whatever shell. It's essentially, that's a good question. Essentially, what we're doing here is just executing on your behavior in the shell. So whatever you alias, it will be there. Yeah. So rm minus f is a convenient way for me to remove a lot of my file, but it has some risks. Okay, as programmer, especially operating system like a Unix, just be careful. rm minus f is actually quite powerful. To recover your file, if you use rm minus f, it's not as easy as window. Okay, if you drop window to the trash bin, there are, at least I know there's a 5 or 6 different way of getting it back. But if you do a rm minus f, wow, that's actually some deep root cleaning to get it back. It's pretty horrible. Just be careful. Yeah. So always make a copy. Okay, always make a copy. I mean, I don't want to hear from you saying that 2 hours before the deadline homework that you said, oh, Professor Wu, I just by mistake, I changed that. I actually, that little star.o, I actually write a star.c. It looks the same, right? C and O, if you, like my age, that. So then you need more time. Yeah. Just be careful. Make a copy all the time. Okay, make a copy. Yeah, you don't want, make it, I mean, for example, if you don't know what make it clean is, just don't write the last rule. Okay, don't write the last rule. Plain rule. I mean, just keep the file there is okay, right? I just don't want you to by accident delete something which is very important, especially if you never use makefile before. Okay, makes sense? Any other question? Yes, please. Okay, so the TA is going to announce their office hour. And pretty much if I don't do this office hour, I'm going to have another office hour somewhere. Yeah. Okay, any other question? Yes.
Yeah, following exactly the way it is.
Yes.
So it's gonna be- which one? It's in the ecs36b.
Now, let's just keep uniformity. Okay, let's just keep it. I mean, it's not hard for you to change that folder name back to anything you want. I mean, you know the Unix command move, just like rename. You can actually change the name, MV, using the command MV. Change. I mean, this is a very commonly used command. For example, I have a directory called ecs36b homework 1. I can actually just change to move ecs36b homework 1 to ecs36b homework 11111. Okay, I just do a change. And then if you do an ls, you see that now I changed the file name, change the directory name. It's not, if there was a command for you to do that. Unix definitely, but a lot of things you can do using the move and v. I better change it back. Otherwise, I will confuse myself. Okay, now I'm back. Any other question? Okay, I think our time is a little bit over anyway. Sorry, almost there. So if you have any question, I will stay here for a few minutes. Okay.
So we'll move to the next one, so we'll-